I introduced myself in the back of the room. My name is Cliff Roberts. I've come here by invitation, basically. So I've been implementing software for about 25 years, and I've seen kind of the beginning and the middle and the end of the business I'm in telecom world. This is my wonderful picture on LinkedIn. You guys can find me there if you ever need to see me. I want to talk about a few things. I see the numbers came out on the agenda. That's good. So I want to talk about who I am, why I'm here, some bit about the data model that we came up with. And the model is being used in the United States, in the lower 48, as well as in worldwide solutions. I talked to a few people in the back, the introductions. I have customers in the Caribbean, Northern Africa, the Middle East, Australia, New Zealand, a lot of Asia, a lot of the Eastern Bloc countries. I did quite a bit of work in Poland, working out of Warsaw, and a lot of war stories about all that. I want to talk about the integrated solution we came up with using OrientDB as a part of the solution, and kind of why we did it and why a graph database fits the model that we have in telecom. And then a bit of a comparison between the relational database that we have and still have, and then the graph database we used in concert with it, and other ways that telecom's using semi-structured data. And at the very end, if the time allows, a little bit of talk about performance. A little trivia here. We talked about blockchain, and I like to talk about this. In my 25 years, my seat has changed, my building has changed, but the top of my pay stub hasn't changed very much other than the logo. I started out moving from New York City, from the Bronx, out to Bell Laboratories, in a wonderful countryside in New Jersey. Bell Laboratories was broken up. Some of it went to Lucent, some of it went to what's called Bellcore. And the nice thing I like to talk about Bellcore is they had a significant large section of research, and the Bellcore researchers, Haber and Stronetta, actually created the algorithm for blockchain. And the paper by Nakamoto actually cites that paper that they wrote. Now, funny story about this is that they didn't find any value in this research and neglected to keep the patent live. Funny, that's the sad story. So everybody's talking about it. Fortune magazine has the cover on it. Everyone wants to be in blockchain. Wouldn't it be nice if you controlled the license for using blockchain? Just imagine the possibilities. So they published it and decided that it wasn't worth doing anymore. So this is a bit of trivia. The eureka moment that made Bitcoin possible was in the Wall Street Journal on May 25th, and I put that article in here. I read it and I was very sad, sent it to all my colleagues and said, gee, if only we knew. So the brilliance of them all. So basically, I work in the same research center I've always been in. I started out pure research in the IT world, and I've slowly moved over to more development. And really, we're in the implementation world full time now. So I want to introduce you to my team back in New Jersey. This is my team back in New Jersey. So exactly. So I'm a big Bloom County fan. So since we're so tech focused here, I thought I'd introduce this to you, introduce you to kind of the people I work with. And also, people always ask me, well, you're heavily into IT. What do you do? And I tell people, well, funny you don't notice about me, but I wear a dress on the weekends. So that's me over in the corner on the left. And the nice thing I like about this picture is every one of the people playing bagpipes in this photograph is a student of mine. So I have 25 people. I brought them to Scotland. I brought them overseas. And it's a fun little hobby we have. So it's what I do in my free time. So let's talk about the data model. And in the telecom world, there's a few ways to look at what would be called a network topology. And this fully connected network model that's up here, that's the, wouldn't it be nice if we had it and had all the money in the world to interconnect everything in our network, which is unrealistic. So we'd like it to be fully connected, but it's really not. Pretty much we have bus, we have somewhat of a mesh, but the three we like to really focus more on is a ring topology, a star topology, and a common bus. So those three are pretty much used in the networks that we work with. So I always tell people when I show this graph, how does a graph database work in this world? Really, really well. How does a relationship database work in this model? Really poorly, right? And so we wanted to really move the significant portion of the value of our data records, which is the equipment, the physical equipment. And I'm not sure if anybody has an experience in the world of the Alcatel-Lucents and the Ciscos of the world, but the cards that are in those boxes are between $10,000 and $20,000 a piece. And when you take that card out of that really expensive piece of equipment and you put it in a closet somewhere, you want to make sure you know where it is, because that's a lot of money that's being stored away in places. So warehousing and being able to track where this data lives is really important in the world I come from. So typical layers in the model I'm in, and let's start with the top, even though it doesn't make sense. This is a tree kind of with the trunk at the top and the branches on the bottom. The physical box, that Cisco box or that Alcatel-Lucent or Tellabs box, is the physical box. So what they're going to do with that is they're going to create logical layers, what they would call layer 2, so to speak, and then below that layer 3, and even more so service layers. And the reason why it's kind of upended like this is because when I'm down here at this layer, I'm trying to ask questions like, who is connected to this logical layer? What kind of services are they using? Where does it live, and what kind of things is it going to do? Well, we have to step backwards to the layer 3, to the layer 2, all the way to the physical layer to do that. So you can see we don't have a single view of this graph. We've got multiple layers of graph on top of it. So you can understand how that single Cisco box or Alcatel-Lucent or Tellabs or wherever it is can literally represent thousands and thousands of objects. So the database gets huge very quickly. So this is what happens in the wireless world. Classic picture. The one on the top is 2G. The one in the middle is 3G, and this is 4G. And I have a picture later on about what 5G is going to be in the world that we're living in now. So you have certain things here. You have the user equipment. You have the things called a radio network controller, a base station controller. These are all physical devices and logical layers that involve the wireless world. The reason why I'm showing this model is I want people to understand in the telecom world where the models apply to how the data is persisted. So this is a simple, if I was in the wireless world, this would be where I would be living. But I've also got things like what we would call Metro Ethernet. Metro Ethernet, very, very simple model, right? I've got provider edge routers in my network. I've got connectivity to my customer end. I've what they call a multi-tendency unit, meaning I'm sharing that with multiple people in multiple places. That's the simple model in Metro Ethernet. This is really what I deal with. Now I'm going to close in on this. You don't have to squint too hard about what this is. But this is a very, very classic model of Chicago, New York, and New Jersey, and where the equipment lives and how they're interconnected. And you can see that the network can get unbelievably complex. So we're going to close in later on that. This is a classic cloud model, and I'm not sure if you can see it from the back of the room, but there are things that we talk about AWS, Amazon Web Services. We're taking the customer data center and moving it into a cloud environment. Well, how the heck does that happen? How do you keep track of that kind of data? So what we've done is we've come up with a cloud model of how you take that data center that's physically in the data centers of a company, and how do you move that into a cloud and have them worry about it. The thing to think about down here is FW's firewall. How does the firewall get handled? How does my DHCP, how does my name to IP number translation going to work? And there's something called CGNAT that stands for Carrier Grade Number Address Translation. The IP numbers of the network are fixed. There's only a certain number of them. But within the corporate network, they can be translated into thousands of unique numbers. So you reuse IP numbers inside the network. But that's very complex because you're going to take this data center and you're going to physically move it into AWS. How do you keep track of the data? How do you know how many service functions are in there? So this is what the telecom companies have to worry about.